Look at this Spring AI app. Sends a request, gets back perfectly structured JSON. Tool calling works, even shows its reasoning. But here is the thing. There is no OpenAI behind it. No Claude, no Cloud at all. This is a 2 billion parameter model that runs on my laptop. And it just did everything I'd normally pay OpenAI for. But I did it locally, just using LM Studio. Let me show you exactly how and why you might never need again OpenAI for your Spring AI app again. Quick context. In the last two videos we built a Spring AI app on OpenAI. Chat with memory, structured output, tool calling, all standard stuff. Most tutorials stop there. But Spring AI's actual killer feature isn't talking to GPT. It's that the same Java code works against any model. OpenAI, Claude, Gemini, Mistral, and yes, models running on your own laptop. Today we are going to switch providers 3 times. First, Claude. Just to prove no-code changes isn't a marketing slogan. Then, and this is the part most devs don't realize is possible, a local model. 2 billion parameters. 2 billion parameters running on my laptop. No internet, no API key, no cost per request. Same Java code. All free. Let me show you. This is where we left off in video number 2. OpenAI configured here in application.yaml. Chat client injected into AI service. Free demo endpoints. Chat, code review and chat with tools. And all working against GPT-4o. Let's verify. What model are you? OpenAI GPT-4. Okay, tool calling. Not tool calling, but code review. Let's see what we have here. Okay, works as expected. Quality score 55. And finally, chat with tools, where we're asking if we need an umbrella, if the weather, like in Riga, as we hard-coded. Okay, everything works as expected. Everything works. This is the baseline. Now I'm going to do something most AI tutorial videos won't show you. I'm going to delete the OpenAI dependency and put Claude in its place. To achieve this, we basically need to do 2 small adjustments. First one, in POM XML, instead of using starter for OpenAI, we are going to use the same but for Anthropic. Let's copy paste it. Here we comment it. And instead of OpenAI, we use Anthropic. Exactly. Let's reload Maven to get this dependency resolved. Okay, and now let's go back to application.yaml, and instead of OpenAI, we are using Anthropic. Exactly. So I have already predefined everything. Once again, use API keys defined in your environment variables, not storing in a plain text. And of course, instead of this GPT-4, we are using Claude Sonnet 4.6. Okay. So the model actually doesn't matter, we are just using the cheapest one. Okay, now let's go back and see what happens. Let's shoot it. What model are you? I'm Claude, made by Anthropic. Wow. Let's now review our code. Okay, 50. Right, so Sonnet is more strict than GPT-4 and quality score is only 50. And back to tooling. Okay, so the thing I would like to highlight that what we just changed. Spring AI swapped the entire backing model with two config lines, one here and one in POM XML. Same AI service, same AI controller, same business logic. But cloud to cloud isn't the interesting part today. Now we go local. Well, and here's something most devs don't question. Does AI need to live in the cloud? Most Java tutorials assume yes. Send the request to OpenAI, get the response back, pay per token, hope your data isn't training their next model. But for a lot of teams, that's a not starter. If you work in a bank, healthcare, defense, your security team will not let you send customer data to OpenAI. In Europe, GDPR makes it complicated even for normal companies. For years, the answer was wait for your company to figure it out, or pay a huge amount for an enterprise license. That changed in 2024 when open weight models got good, and by 2026 you can run a model on your laptop that doesn't most of GPT-4 did in 2023. No kind of works, not good for autocomplete, actually works. Structured output, tool calling, reasoning, everything. And let me prove it. Now we are going to start LM Studio. Free on Mac, Windows, Linux. Think of it as a Docker for language models. Okay, let's go to developer. And you see we have our server already started, reachable at localhost 1234. And let's load a model we will use. I have a number of models being downloaded here. And for demo purposes, we will use this Gemma 4 with 2 billion parameters. Let's load it. It's been loaded, as you see. And the most exciting part, as you can see, supported endpoints. We have 3 types of endpoints available: LM Studio API, OpenAI compatible, and Anthropic compatible, meaning that we can actually switch the model to the local one if we used, for example, a model from OpenAI or from Anthropic. Since we have already used a model of Claude in the previous demo, we are just leaving as it is, right? But the same dependency, the same configuration. The only thing we should change now is we need to specify base URL to point to our localhost, right? We can copy it from here. Base URL and the model. Okay, the model. Let's copy. It's Google Gemma. Copy. 2 billion. Once again, 2 billion parameter model. Okay, and that's basically it. But can you imagine just 2 billion parameters? 2 changes, model and base URL. And of course, we should change API key. Once again, it should be predefined as an environment variable. LM Studio API key. Let's restart. Okay, very good. Now let's get back to Postman and see what model are you. Let's launch it, and you see here is the request coming in. Very good. I'm Gemma 4, a large language model developed by Google DeepMind. Wow, that's cool. It's working locally. The model on my disk just had a conversation with me, right? Wow. This is the actual inference happening, not a relay to some server. The computation is happening on my CPU and GPU right now. Now, just a quick reminder from video 2. This is the code review we did with you, right? Code review class. So we defined a structure we would like our model to return the answer to our question. Let's see how that works on 2 billion model. Here is our endpoint, our body with text. Just let's send it and see what happens. Let's switch back and see how it's processed. So this is the input. Review this code, okay? And here is the output. You see? Here is the output. Exactly. Here is the output from my local model. As you see, quality score is also 50, so it is as strict as Anthropic Sonnet. But GPT-4 in this case is the less strict. Perfect JSON, schema conformant, and it's correctly identified the bug, right? Using this instead of equals. A classic Java gotcha that costs production systems real money. A 2 billion parameter model on my laptop just code reviewed Java better than some juniors I have worked with. Now let's test. What is the weather like in Riga and should I bring an umbrella? Let's go back. Okay, here you can see. So it got the content, cloudy, -4, -2, yeah, based on Riga input. Okay, here it works, and here is the answer. Okay, umbrella, no rain is reported, so likely don't need one. So the model decided I need the weather tool, Spring AI calls our function, we return mock data and model wraps it into natural language. Same code path as OpenAI. Same code path as Anthropic Claude. Same tool annotation. Different models on my laptop deciding to call my function. This is what people don't believe is possible with 2 billion model. But it just happened. Just twice. Okay, but maybe you don't believe me. Maybe you think there is a sneaky cloud call somewhere. Let me just prove it. Let me prove it. Let's go here and just do a flight mode. Okay, so let's entirely disable everything. So you see we are in flight mode now, and let's go back and see what happens. Let's chat. Are you still alive? Still alive. Yes, I'm a large language model. So you see, we got an answer, still working, because everything, the model, the inference, the JSON parsing is happening right here, on this machine, disconnected from the internet. Let me put this in perspective. GPT-4 rumored around 1.8 trillion parameters. The model we just ran, just 2 billion. That's 90 times smaller, and it just did structured output. Tool calling, code review on a laptop, completely offline. 3 years ago, this was a science fiction. Today, it's a Maven dependency and couple of lines of YAML. So the question, why should you care? 4 reasons. Cost. Every request to OpenAI on Anthropic costs your tokens. Locally, 0. If your app makes 1 million LLM calls a month, that's a real bill versus electricity. Privacy. Your data never leaves your machine. Customer records, internal documents, source code, none of it goes to OpenAI or Anthropic servers, none of them train their next model. And compliance. Bank, healthcare, defense, UA companies under GDPR, they often legally cannot use Cloud AI. Local inference unlock these markets. Offline development, build AI features on a plane, demo your app at a client site with no internet, develop in environments where the cloud doesn't reach. Now, is local always the right choice? Of course no, the cloud models are still smarter. If you are doing complex agentic workflows or you need the absolute best reasoning quality, OpenAI or Claude will outperform a 2 billion model. That's logical. But for 70% of business use cases, structured output, classification, summarization, simple agent loops, local is enough. And Spring AI makes it free to find out. 3 lines of YAML, same code, just test it now. So, quick recap. OpenAI to Claude, 2 config lines, same Java. Claude to a 2 billion parameters local model, just also a couple config lines, same Java. Structured output, tool calling, all of it worked locally, offline. This is what Spring AI's chat client abstraction is actually for. Not use OpenAI in Java. That's the boring version. The interesting version is use any model from anywhere with the same code. That's what makes Spring AI worth using over calling APIs directly. So if this changed how you think about Spring AI, hit subscribe. Next video in this series, we are going further, building a multi-model setup where the cheap local model handles 90% of requests and only escalate the hard ones to GPT-4 or Claude. Cost optimization meets architecture. See you then. Bye bye.